This last example, 3, they want us to select a strategy. This time they're not looking for a particular side or a particular angle. They just tell us solve this triangle, which again solving means finding all the angles and finding all the sides. Once again, first law of sines, and I'm putting a question mark because I'm asking, can I use law of sines? No, because remember, law of sines requires opposing pairs, both the angle and the opposite side must be known. But if I look for any of those, like if I look at K, I know the angle, but I don't know the opposite side. L, I don't know the angle, I do know its opposite side, but I need to know both for me to use law of sines. So I know that this one, and this is not a right triangle, and I cannot assume, it might look like it's a right triangle, but I cannot assume that it's a right triangle, so I have to use law of cosines. So now on this one, which one is, are which opposing pair am I going to use here? Okay, okay. This one right here is the opposing pair, and that's going to be the outer one, the outer angle. So I'm going to call this one sort of my hypotenuse, and then this one would be the legs. And again, in quotations, because this is not really a right triangle, definitions don't really apply, but it does help us set up the law of cosines to avoid having to memorize all those formulas, or even if I give you a formula chart, it can be very confusing with all those variables. So once again, it's going to be the hypotenuse squared. So it's going to be k squared is equal to the legs squared at the summation of that. So it's going to be 14 squared plus 18 squared minus what? 2 times what? 14 times 18. Good, because remember that these two basically, the 14 and the 18 also have to match here. And then times cosine of what? Of 51 degrees, because it's the angle between those two legs that we identified here. I need to solve for k. Notice how k is almost isolated by itself on one side of the equal sign, but how do I undo or get rid of that square? Square root. I'm going to just show, that this is the square root, and I'm going to take the square root of both sides. Now, once again, k is equal to this above, but go ahead and give me the calculator approximation for this right here. Okay, 14.24 or 14.2. Now that I found that this right here is 14.24, now can I use law of sines? Yes, good. Because now I know the opposing parent and the opposing side and angle. So now, law of sines. And why can I jump from law of cosines to law of sines? Because I just mentioned that now I know that the angle here and the opposing side are both known. So let's start with that. And don't forget, law of sines is going to be, what was law of sines? Right? But then how do I set it up? It's sine of 51, the angle, over what? Over 14.24, the opposing side, is equal to, and now you choose. Do you want to find angle L or do you want to find angle M? It's a choice. All right, let's go with M. So if I try to solve angle M, it's going to be sine of what? m, or you can use any variable x that you like over 14. Now, since I'm finding an angle, I know I have to use inverse trig, but still, let's cross multiply. First one with the angle. So 14.24 times sine of angle M is equal to 14 times sine of 51 degrees. Remember that I need to solve for M. So I need to isolate the times, I'm sorry, I need to isolate the sine of M, so I need to get rid of times 14.24, so I have to divide by 14.24, divide by 14.24. This is 1. That way I end up with sine of M is equal to this right here. Once again, since I had mentioned that you're looking for an angle, I know I need to use inverse trig, and in fact, I need to use inverse trig to undo or get rid of this sine. So I'm going to say sine inverse of both sides. And I get that M is approximately equal to, and I suppose on this example, you know, I guess we could put the equal sign, but because we kind of already rounded on this side, it might be useful to maybe just say that it's already an approximation, but that's fine. Just at the very end, at least tell me that it is going to be an approximation. So go ahead and enter this into your calculator and tell me what you get. I'm sorry, what? 0.76? Or is your calculator in degree mode? Check that. All right, let's look at your responses because I'm curious to see how you guys are typing this on your calculator. Okay, I'm seeing 49. I'm seeing the 49.8224. Let me see if I can find that 0.70. Okay, there we go. So just be careful. Note the difference between how you type it on the calculator. Here you see this right here says sine inverse for and then or inverse of sine, and then they type all this, and they got 49.824. And the ones that the one if you got the 0.76, note the difference that you kind of needed to type in. You were this person's probably still typing it right here, but you cannot just leave this by itself. Oops. You kind of have to type all of this with the sine inverse in front. So just be careful on that right there when you type it into the calculator. So yes, the correct answer should have been this 49.82. Now this is a degree. Okay. Now the last thing, of course, I'm going to put that this is 49.82 degrees. How can I figure out angle L for the last step? Well, I could use the same thing, law of sines, but now if I wanted to avoid having to do law of sines, yes, subtracted from 180, the summation of the angles, we know that the sum of the angles is 180. So now just simply do this right here. Now in this types of examples, notice how the directions did kind of specify round to the nearest degree, round to the nearest tenth. I would suggest that you keep your answers to 2 decimal places, rounding off correctly, that is to the nearest hundredth. And at the very end, once you're done with the problem, should it be multiple choice, or should, when you're plugging in your answers into the calculator, then round your answers. Because if you start rounding, like for example here on the 14.24, if I start rounding here and I use it to find this one, it might give me a different response or a different answer. So just be careful on the rounding.